the section 3 of our unit 3 of our financial modeling course. In the section 3 of the unit 3 of this course, we are going to consider the diagnostics on the independent variables. By the end of this session, you should be able to test the significance of the independent variable in your regression model. You should also be able to specify the final regression line. The independent test of significance. So here the focus of this session is to test the individual parameters and to see if they are significantly different from 0. So the test will focus on the table 3.1, which is our table for the goodness of fit, as well as that of 3.2, where we were estimating how the parameters like the income, education affects a customer's credit ratings or credit worthiness. So the test will focus on the regresses only, because we said that we are focusing on the test of significance of the independent variable. So we have income represented by IN, ED being education, G being gender, and the S representing the student status, with their corresponding parameters B1, B2, B3, and B4 respectively. So you could see that we have, in testing significance, we have the null hypothesis and the alternative hypothesis. The null is given or represented by the H0, which is this portion, and the alternative is the H1. So our null hypothesis for the first parameter, which is the income, was that our beta coefficient, which is the B1, is equal to 0, which is we are estimating that it is insignificant. And also the alternative is that our beta coefficient is not equal to 0, which is B1 is not equal to 0, which is the heart represent the estimate. Is not equal to 0, so which means the income level is actually significant in explaining the relationship between the credit worthiness and or establishing the credit worthiness of a customer. This is in equation 3.1. Our null for the education parameter is also the same or is similar. So our null is that education is significant, which is the H0, and the alternative is that education is significant. So the null is like saying there is no or there is no relationship or it's not significant, and the alternative is that it is or there is a relationship or it is significant. So student status is significant, that is for the fourth parameter by the null hypothesis, and the alternative is saying that the student status is actually significant. So we could say that our null is saying opposite of what the alternative is saying. So as our null is saying that it is not significant or it is not significantly different from 0, the alternative is saying that it is actually significantly different from 0, or the parameters is actually significant. And these are assumptions, or these are estimations that we made on our own based on empirical studies. The t statistic is defined as we see in this equation, that is t is equal to the beta hat all over the standard error into bracket the beta hat. So this is how we estimate, or this is how we come about by the t statistic that we see in our output plot, or so the output table. The p-values represent our evidence in support of our null hypothesis. So the p-value will tell us as we should reject or we should fail to reject our null hypothesis based on what the null hypothesis is saying. As a rule of thumb, we need at least 5% significance level, which is the alpha level, is what we call the significance level, in order to either accept or fail to reject. So we either reject or we fail to reject. So our acceptance of the null hypothesis is simply saying that we have failed to reject the null hypothesis. So for a parameter to be significant, usually at the 5% significance level or the 5% alpha level, the level of significance will fall between the following, or the following apply. That is, we have to ask ourselves the following question as to whether the standard error will be less than the estimate. So if the standard error is less than the estimate, then we are assuming that our model or the estimate is quite significant. And also we have to check whether the absolute value of the t statistics is at least 2, so which is it should be greater than 2. And we should also check whether the p-value is less than 5%. So the probability value should be less than 5, as we saw earlier in our table or in the output table, where the education had over 0.76, which is 76%, indicating that it is not significant at that level, as well as that of the gender, which had over 20%, indicating that it is also not significant. So our significance level was 5%. So anything above the significance level shows that it is not significant. The zero value does not lie in the confidence interval, so we should also ensure that the zero value does not lie in the confidence interval. So the value between the critical value should not be found within the zero line. It should not be significantly different from zero. That's what this one simply means. So our coefficient or our p-value should not be found between, or should not be significantly different from zero. Interpretations of our results. So we earlier said that after estimating our model, we cannot put those model estimations to use until we've been able to evaluate those model results and also interpret those results to see whether they are significant or they are fit for our use. So for instance, in our table, that's table 3.1, 3.2 up to 3.4, it was made clear that there were some output that were reviewed from our estimations, and we are going to interpret those results in this slide. If we take IN, which represent income level, for instance, it has an estimate or estimate coefficient of this is beta 1. So the beta 1 coefficient is representing the income estimate coefficient, which is 2.0800, which is higher than the standard error of the equation, which was 0.04039008. And also the t statistics of 24.35735 is far higher than the standard of 2. So we always set a standard of 2 to be our t. So if the t statistics is higher than 2, we assume that it indicates the significance of our model or the estimation coefficient. The p-value is also less than 0.05, which we earlier said that we have 5% significance level, or we set a 5% significance level, and any value higher than this significance level indicate that that value is not significant, or the value is not significant. And finally, our confidence interval, which measures the difference between, or which is plus or minus the constant parameter plus the t statistics. So here 134.43 is the represent the constant parameter minus or less the t statistics, and also this is the constant parameter plus the t statistics, indicating that we have a value which does not lie between 0, because 134.43 and 158 has no, or does not rest between, or does not lie between 0. So we don't have any negative value here, which indicate that this value is also significant. All these pointers, or all these values, or all these results together lead us to reject another hypothesis that the income level is not significantly different from 0. So in summary, we cannot say, or we cannot conclude that the income level does not significantly, or does not significantly influence the credit worthiness or the credit ratings of a customer. In contrast to the income that we had earlier, the education, or the ED, has an estimate of 0.120696 as against a standard error of the beta coefficient of 0.40194821, which indicate that in summary our standard error is even higher than our estimate coefficient, And also we have a t-statistic which is less than the standard of 2, and a p-value of 0.76413. All these indication together with the negative confidence interval, which shows that our value lies between 0 and 0.91092, indicate that we have to fail to reject the null hypothesis that this education is not significantly different from 0. So in summary, we are simply saying that due to all these factors that we have earlier mentioned, everything indicates to the fact that the education is not significant or is not significantly different from 0, and that it does not contribute in explaining the movement in the regression, which is the credit risk or the credit ratings of the customer. Also, the parameter of gender B3 is similar to that of education, so we have to filter reject the null hypothesis and indicate that the gender is also not a factor in explaining the credit ratings or the credit worthiness of a customer. But on the other hand, student status is similar to that of income. So here we also say that the student status could also contribute to the explanation of the credit ratings or the credit worthiness of a customer. So we have to reject the null hypothesis that the student ratings is not significantly different from 0. It is now evident why in the final model, that is 3.4, that is table 3.4, we have to remove parameters like the gender and also education, because both do not contribute in explaining the movement in the credit ratings, that is the regression. We can state our final regression model or regression line and interpret the coefficient accordingly. So in the final regression line, we have the equations such as CR, which is the beta coefficient, which is the constant, plus the beta 1, which is the income, plus the beta 4, which is the student level, and the beta 5, which is the balance or the bank balance of the customer. So we can now estimate our regression model as the CR equals to 149.3993, which is the constant, plus 2.0790 of the income level, minus 98.361 of the student, that is the student status, and the 0.23389 BL, which is the bank balance. So this is how we are going to estimate our regression model using the result that we had from the equation or the table 3.4. It is important to understand that in our earlier interpretation of our regression model results, we had students as a portion or as a parameter, that is beta 4, to be a categorical or a dummy variable. We should understand that interpretation for the dummy variable will actually be different from that of the other variables. So for being like, for instance, we in our estimation or in our model, we made it clear that 0 represent being a student and not 1 represent being a student and 0 represent not being a student. So our reference category is not being a student. Dummy variable parameters are always explained from the reference category. According to the equation 3.16, the beta 4 indicates that on average, the credit rating score of a student will be around 99, less for students than for non-student, holding other things constant. So determine if the student test, that is the student being the parameter for being a student, that is beta 4, are being discriminated against in terms of credit rating scoring, or in terms of the credit rating score, given that it's a dummy variable. We need to test the following hypothesis, that is as to whether beta naught students are not discriminated against, or beta the null hypothesis, which is the H naught, that is whether students are not discriminated against, or the alternate hypothesis, whether students are discriminated against. So in testing for this hypothesis, we have to use the WAL test, which we will do in our next table with the help of the eView analytical or statistical tool. So as we mentioned earlier, with respect to the testing of whether the categorical variable or the dummy variable, that is the student status, has either been discriminated against given the value that it was shown in our earlier output or earlier result. We said we're going to use the while test on students to test whether they have been discriminated. So the while test results are shown in our table 3.5. So this is the output for the while test, and this is the method that was using and that was used. This is the test statistic. So we have the statistic value of 32.888. We have a degree of freedom of 396, indicating that we were using 400 number of observation. We have F statistics. These are all values that are from the while test. So in the while test, we gave or we had the null hypothesis that the student have not been discriminated against, and we have the alternative of that they have been discriminated against. So given that we have a p-value of 0.000 for both the t statistics and other statistics, we can now conclude that the value or the parameter that is v4, which was estimating the influence or the student, how your status as a student contribute to your credit worthiness, have significantly been discriminated against. So the 0 p-value indicates that the null hypothesis, that is as to whether the student has been discriminated against in terms of the estimation of the actual model, is strongly rejected, and thus we may conclude that students may have been discriminated against in credit rating. So here we reject the null hypothesis that the student has not been significantly discriminated. So we reject that null hypothesis and conclude that the student has actually been discriminated against in the calculation or in the estimation of the regression model for the credit ratings. In summary, we've been able to test the significance of the independent variables in our regression model. Even though we're not done, we will continue in the next session. We will be able to test the significance of the independent variables in our regression model using some form of or some criteria like the p-value, the test statistic, and the coefficient or the estimate coefficient, among others. We have also been able to specify the final regression line. Welcome to the end of today's discussion. Thank you for your attention.